Engineering acoustics is a very important field that affects our everyday life, whether we know it or not. Even though it is so widely used, it does not seem to be thought of when thinking of future careers. My name is Jeremiah Rogers, and I will be defining engineering acoustics through examples and comparisons. Often when someone hears the term engineering acoustics, they think of sound engineering, as in someone who works in a studio and mixes recordings of musicians, or someone who works at a concert hall setting up the sound equipment. This is vastly different from engineering acoustics. Rather than just setting up or using the equipment, an acoustical engineer would be the one who designs and creates the sound recording equipment. In order to work in engineering acoustics, one will need a bachelor's degree in some sort of engineering field, such as electrical or mechanical. This requires a greater understanding of math and science than what is required in sound engineering. Within the broad definition of engineering acoustics, there are many smaller subcategories that one could study. One of the biggest applications being architectural acoustics. This is the science and engineering of achieving a good sound within a building. This is extremely important for civil engineers who design any sort of auditorium. If designed without acoustics in mind, the sound from a stage may die out very rapidly and not travel to the far reaches of the auditorium. An acoustical engineer would design the auditorium to enhance the distance sound can travel. As well as creating rooms that enhance sound, architectural engineers create rooms that stifle all sound inside them. This is very important when recording. If you are listening to a song, you don't want to hear the buzz of a venting system in the studio. That's why an acoustics engineer would design a room to isolate the sound being recorded. Electroacoustics is near and dear to my heart because I am studying electrical engineering, and electroacoustics is focused on taking a physical acoustic waveform, converting it to an electrical signal, manipulating the waveform for a desired effect, and then converting the signal back to a physical audible signal. This shows up in microphones, speakers, amplifiers, and any effect you have heard in music. An electrical signal can easily be amplified to a higher voltage, which translates into a louder sound. Using electrical engineering and signal processing, we can change the pitch, tone, or virtually anything relating to the sound sent into the system, and replicate it at whatever volume necessary. These are only a few of the fields that are classified under engineering acoustics. A big one that has many applications in biology is ultrasound, which deals with the sound that has a frequency higher than is humanly audible. This can be used to penetrate through solid materials in order to detect objects. Sonar is another major application. It works by simply sending out an acoustical signal and detects the speed of which it is reflected back in order to determine the distance and shape of objects at a distance or which cannot be seen. This is used heavily in military application. There are so many more applications that exist, such as finding ways to lower noise pollution, creating noise cancellation, speech and speech therapy, or finding the application of vibrations. I hope after this presentation you have a greater understanding of what engineering acoustics is and how it is so much different than audio engineering. Everyone experiences it on a daily basis without even realizing it. Any future or beginning engineer should consider engineering acoustics as a field in which they could study, as it is much broader than just music. This has been Jeremiah Rogers. Thank you for your time.